afternoon, everybody. Here we are in the Aloe and restaurant in Stanley Street, Montreal on Friday, February the 17th, 2012. And I'm going to introduce to you the second of two videos, this one called An Introduction to Magic Squares from India. And it was an invited talk presented as a video on the 10th of January 2012 at the International Workshop and Conference on Combinatorial Matrix Theory and Generalized Inverses and Matrices, held at Manipal University in Manipal, near Udupi, Karnataka, India, from the 2nd to the 11th of January 2012. This particular talk, the second video, is based in part on an invited talk, also available as a video. The talk was presented in the Frederick V. Pole Colloquium in the History of Mathematics, hosted by the Department of Mathematics and Computer Science at Adelphi University in Garden City, Long Island, New York, on the 13th of October 2010. This research was supported in part by the Natural Sciences and Engineering Research Council of Canada. Hello, everybody. I want to tell you about magic squares from India and to show you images of some related postage stamps. But first, a little history. Legend has it that the very first magic square was discovered in China about 4,000 years ago on the back of a turtle or a tortoise. On the left stamp from China, you'll see a small turtle as to where we believe the Luo River was, and on the right you'll see an Aldabra giant tortoise on a stamp from India. Until at least the year 1533 AD, the topic of magic squares was part of occult philosophy. More recently, however, magic squares belong to recreational mathematics, and Karl Ock is enjoying teaching his older son the beauties of magic squares, his older son being aged 5. And only for the past 50 years or so have they been studied in a matrix theoretic setting. As many of you probably know, Cleve Moeller in his MATLAB package has a magic procedure or algorithm, magic of n, which generates an n by n magic square. His first description of this procedure was in the article MATLAB's Magical Mystery Tour. My main interest, however, is not in the Beatles, but in the history of magic squares and the related magic matrices. The magic square that you see on the screen now is known as the Luoshu or Luoshu Luo River writing, and it's the 3x3 classic fully magic matrix, the first one, I guess, that was ever considered by anybody. In this matrix, you'll see that the numbers in the rows, columns, and two main diagonals all add up to the same magic sum, 15. When only the numbers in the rows and columns, but not the two main diagonals, add up to the same magic sum, then we have a semi-magic matrix. The n by n magic square is classic when the n squared entries are 1, 2, up to n squared. There have been many magic squares associated with India, and you'll see on this map that they come from Gwalior, Kanpur, Jhansi, Surat, Nasik, Hyderabad, Mysore, and now Manipal. The oldest magic square from India is credited to Varāhamihira, and he had a 4x4 magic square, which you see displayed there, which is not classic, because each of the integers 1 up to 8 appears twice. This is apparently, according to Hayashi 2008, the oldest datable magic square in India, and it occurs in the Brihat Samhita, the Sanskrit encyclopedia on divination by the 6th century Indian astronomer, mathematician, and astrologer Daivanyai Varāhamihira, who lived in the 6th century AD. Varāhamihira showed how to make several varieties of perfume with precisely 4 substances selected from 16, including agar wood, which yields oud, perfume oil. Varāhamihira used the magic square defined by the 4x4 fully magic matrix that we just discussed, which is not classic because the integers 1 up to 8 each appear twice, but it is Nasik. The term Nasik is synonymous to pan-diagonal, meaning that all the diagonals parallel to the two main diagonals all sum to the same magic sum. The term Nasik for this property was coined by Andrew Hollingworth Frost in the late 19th century. He was a British missionary in Nasik, India, 1853 to 1869. And you see there a picture of Nasik, also pronounced or spelled Nashik. We define an n by n magic square to be pan-diagonal or Nasik whenever all two n-diagonal paths with wraparound parallel to and including the two main diagonals are magic, as in the Varāhamihira magic matrix. It seems that Varāhamihira used 16 substances, as in the table at right. This is according to some Sanskrit text that you see there. That English translation is by Bant of Varāhamihira's Brihad Samhita. So you can see that the substances were agarwood, bay leaves, frankincense, lichen flakes, panic grass oil, etc., all the way down to turpentine. To obtain a perfume mixture, Varāhamihira mixed together precisely 4 of the 16 substances, provided that the corresponding numbers added up to the magic sum of 18. That is the row and column total and the diagonals total of the magic square that we just saw. For example, using the first row of the Varāhamihira matrix, 2 over 18 times agarwood plus 3 out of 18 bay leaves, 5 out of 18 frankincense, 8 out of 18 lichen. We conjecture that Varāhamihira could have made as many as 172 different perfume mixtures in all in about 500 AD. That's 1500 years ago. I've told you that I want to illustrate my findings with postage stamps, and a particularly attractive set of postage stamps comes from Qatar. And there you will see on the left agarwood, in the center 2 stamps, oud perfume oil and agarwood. On the far left is al-marash, a perfume pot that is used to spray a nice smelling liquid on visitors, which is a sign of hospitality and welcome. And on the far right, al-mogbas, which we know nothing about. That sheetlet of stamps from Qatar was impregnated with sandalwood, but there are also stamps from India that are impregnated with sandalwood, and I would like those guys that are going to be there to bring me back these stamps. Now, spices of India were also displayed on a very nice sheetlet of stamps in a kind of rhombic format, and we'll talk more about rhombic formats in a little bit. Here you see cinnamon and 6 other spices. There are actually 3 spices on the middle stamp. Varāhamihira probably created the Nasik magic matrix V1 from a classic Nasik magic matrix with the entries 1 up to 16. A likely candidate is V2, and subtracting 8 from the entries in blue yields V1. Rotating by 90 degrees counterclockwise yields the so-called Plato magic matrix, which apparently has absolutely nothing to do with the luminary Plato. I'll have to look up a little bit about the real Plato. But, as I'm sure you all know, the Maharaja Suraj Mal, who was ruler of Bharatpur, Rajasthan, was described as the Plato of the Jat people because of his political sagacity. He is on a postage stamp, as you see in that overhead. The next overhead, you see on the left, Lakshmi Bai, the Rani of Jhansi, and on the right, one of the statues from Khajuraho. Our second oldest magic square from India is defined by the Dudhai-Khajuraho magic matrix, which you see there is also Nasik. The matrix D corresponds to a magic square found in Dudhai, in the Jhansi district, and in Khajuraho, which is in Madhya Pradesh. The Dudhai magic square was carved on the underside of a lintel from the collapsed doorway of a shrine known as the Chota Surang, a small tunnel. That is reported in several papers, including a seminal one by Kamen. The stamp that you see here depicts Lakshmi Bai, the Rani of Jhansi, queen of the Maharaja-ruled princely state of Jhansi in the 19th century, and a symbol of resistance to British rule in India. The Khajuraho magic square, which dates also to the 11th century AD, was found in a Jaina inscription in the Parshvanath Jain temple and or on the front wall of the Jain temple Jinanatha. The next magic square dates from 1300 and is described in the Ganitasārakaumudi, the Moonlight of the Essence of Mathematics, by the Jain polymath Thakura Feru, who lived in the early 14th century, late 13th, early 14th century, and he gave a method for constructing odd-order magic squares. In particular, here is a 5x5 one that he constructed. I would like to mention that the Moonlight of the Essence of Mathematics, which was first published in the early 14th century in Sanskrit, was recently republished in English and typeset in LaTeX. It's an absolutely beautiful book. If you like, it's on recreational mathematics. It has a very nice chapter in it on magic squares. And it is by Sakya, the foursome Sarma, Kusuba, Hayashi, and Yano. Feru's method is described in the Moonlight book on pages 171 and 172, and the basic idea is to take the middle column, put a 1 at the bottom, and go upwards by n+1, and then there is an algorithm for doing the rest of it, which is quite simple. It's not generally known that this algorithm was already known as long ago as the year 1300. Modern writers attribute it to Simon de la Loubère, who spent a long time going to Siam and then coming back again, and it is sometimes called the Siamese method. The Feru magic matrix, as you can see, has these numbers in red, 1, 7, 13, 19, 25, going upwards in arithmetic progression. The matrix formed by flipping the rows of P, and the methods for its construction were given by the French diplomat and mathematician Simon de la Loubère. But Simon de la Loubère learnt the method from a Monsieur Vincent, a médecin provençal, a Frenchman who was in India and got on the boat that Simon de la Loubère was on, sailing back from Siam to France in the late 17th century. Monsieur Vincent, about whom we know nothing, had apparently, almost nothing. He claimed that he had learnt it in Surat, which is in Gujarat, and the image there is of the Surat airport. So if you wish to fly via Surat, this is what to look for at the airport. Our next magic square is from the late 15th century. It was discovered in Gwalior, and you'll see it there with the entries in Sanskrit, and on the left is a stamp from the fort in Gwalior. It was, however, not found in the fort in Gwalior. It was found in an old temple in Gwalior, and it bears the date 1483. It was discovered by a Captain Shortreede, who wrote in the beginning of his article, "As everything tending to throw any certain light on the antiquities of India has an interest, I send you the following inscription of a magic square, which I copied last year from an old temple in the hill fort of Gwalior." It bears the date 1483. The article was published in the Journal of the Asiatic Society of Bengal which happens to be in the McGill Library. So the magic square that you see on the next overhead gets converted into our numbers as the matrix G, and we're going to call it the Gwalior Shortreede magic matrix. You see that it's Nasik. The article was signed by Captain Shortreede, who has two E's in the later part of his name, but we believe that he was actually Shortreede with only a single E there at the end, and he became a major general. He spent a lot of time computing logarithms, and there are many books on logarithms that were published in the 19th century, written by him. Several of these books are in the McGill Library. We think that extra E is a typo. Robert Shortreede was born in Scotland, or near Scotland, in Jedburgh, halfway between Edinburgh and Newcastle, and died near London. Went to India in 1822 and was appointed to the Great Trigonometric Survey, in which he remained until 1845. The Great Trigonometric Survey, or GTS, was piloted in its later stages by Sir George Everest. Mount Everest was named in Sir George Everest's honour, despite his objections. The first ascent of Mount Everest was on the 29th of May, 1953, as you see in this beautiful stamp sheetlet from India. Nain Singh Rawat explored the Himalayas for the British, and Radhanath Sikdar was an Indian mathematician who calculated the height of Peak 15 in the Himalayas and showed it to be the tallest mountain above sea level. Peak 15 was later named Mount Everest. You see both Rawat and Sikdar on this also very attractive stamp sheetlet from India in honor of the Great Trigonometrical Survey. Shortreede made the observation that the Gwalior magic matrix has the numbers 1, 2, 3, 4, satisfying a rhomboid property. That's also true, as Shortreede noticed, that the same property is satisfied by 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. We will say that such a magic matrix with a rhomboid property is rhomboidal. In Wikipedia, a rhomboid is defined as a parallelogram in which adjacent sides are of unequal lengths. The angles are all oblique, meaning not equal to 90 degrees. A parallelogram with sides of equal length is a rhombus, and a parallelogram with right-angled corners is a rectangle, and a rectangle with all sides of equal length is a almost magic square. I want to illustrate these findings with postage stamps in one of my very favorite stamps. It's from the Netherlands, colleagues the Ammerlaan brothers come from, and for a long, long time we tried to work out what it was that was actually on this stamp. Now, the Scott Catalogue, which gives information about the content of stamps, describes the stamp as a rhomboid with yellow lines. But as you can see, these two rhomboids that are there are actually squares, each tilted at 45 degrees. The Dutch Postzegel-Catalogus, which we got from Uncle Leo on loan, identifies the stamp as compositie met gele linien, composition with yellow lines. The Ammerlaan brothers and I tried to find that painting in The Hague, but it was out on loan, it wasn't there. It was painted in 1933 by Piet Mondrian, who lost his second A at some stage in his later life, and the title that we understand is the formal title of the painting is in English, Lozenge Composition with 4 yellow lines, or in Dutch, Rietvormige Compositie met 4 gele linien. But what is on the right of the stamp? Is that another painting by Mondrian? No, it's Mondrian's elbow. This particular posture of a human being, also known as a teapot elbow, is a favorite posture these days by female models. We believe that the stamp is based on a photograph by Charles Carston of Piet Mondrian with his 1933 painting, and it was taken in Mondrian's atelier in Paris at the 26 Rue des Départs near the Gare Montparnasse in about October 1933. The next magic square requires a visit to London. The so-called Hyderabad Queen Mary Magic Square plate that you see there is now in the Victoria and Albert Museum in London, and it dates from 1775. In the middle, you will see a magic square. It was made in about 1775 in Jingdezhen, China, known as the porcelain capital of China, and it was kept in the treasure room at the Golconda Fort in Hyderabad, India, where I was happy to go with my friend Beg 10 years ago. It was presented to Queen Mary, as she then was the Princess of Wales, in 1906, when she toured India with the Prince of Wales, later King George V, grandfather of today's Queen Elizabeth. If you transcribe the Sanskrit characters from that magic square, you will get the matrix H1, and you will see that the row and column totals are, however, not all equal. It is suggested that a few mistakes may have been made because the engraver had difficulty interpreting the Arabic characters. The plate, by the way, is filled with quotations in Arabic from the Quran. It has been suggested that matrix H1 could have come from the classic magic square H2, and if we subtract 40 from every element of H2, we get V3, which we saw earlier as the Plato magic matrix, and I remind you of Maharaja Suraj Mal, the Plato of the Jat people. Our last magic square has to do with the Rajah of Mysore. I'm really sorry that I was not able to join you guys on this trip to Mysore these last couple of days, but I look forward to hearing from you of that adventure. The Rajah of Mysore lived in the early 19th century, and it is supposed that he created what is known as a Magic Nights tour, that is a semi-magic square, in 1852. As you see in the image on the right, which I apologize isn't very clear, but it's the best that I could find, it's embedded on a textile made of silk. There was recently an exhibition of magic squares on textiles in Toronto, but this silk was not there. Indeed, this silk, the whereabouts of this silk are not known. So if any of you happen to see it in the last couple of days, or at any other time and know where it is, please let me know. A knight's tour consists of a knight that moves according to the red lines that you see here, from square number 1 to square number 64, and visits every single square precisely once. That is known as a knight's tour. It's called a magic knight's tour if the resulting array of numbers, here 8 by 8 on an 8 by 8 chessboard, is such that the rows and the columns all sum to the same magic sum. Then it's called a semi-magic knight's tour. And if perchance the two main diagonals also sum to the magic sum, then it's known as a fully magic knight's tour. The first magic knight's tour of any kind was found by a William Beverley in 1847 in England, and it's a semi-magic knight's tour. The two main diagonals do not sum to the magic sum. In fact, there is no 8 by 8 fully magic knight's tour, as was shown in 2003 by an extensive computer enumeration of all possibilities by the international team of Günther Stertenbrink, Jean-Charles Mérignac, in Uig Mackay, after 61.5 days of extensive computation. Also in 2003, it was shown by Awani Kumar, who I understand to be the Divisional Director of the Social Forestry Division in Kanpur, that there do exist 12 by 12 fully Magic Nights tour. And here is one of them. The first 12 by 12 semi-Magic Nights tour, however, was found in 1852, so 150 years ago, by the Rajah of Mysore, Krishnaraj Vadiyar, of the Vadiyar dynasty. The Rajah of Mysore also found the 8x8 semi-Magic Nights tour displayed on a silk, present whereabouts unknown. Until 1947, Mysore was the capital of the Kingdom of Mysore. Since 1973, Karnataka. Manipal is, of course, in Karnataka. It was ruled by the Vadiyar dynasty. The Vadiyars were patrons of art and culture and contributed significantly to the cultural growth of the city. Mysore Palace that you see there is supposedly the second most visited tourist attraction in India after the Taj Mahal. As I mentioned earlier, I'm very disappointed that I couldn't join you all in Manipal at this time, and in particular on the tour to Mysore, which I understand took place in the last couple of days. In fact, I wonder if anybody saw the Rajah silk with the Magic Nights tour on it. My email address is styan@math.mcgill.ca. I would also like to add that there are other magic squares from India, which I had in fact in an earlier version of this talk, but do not have time at this moment to tell you about. If there is any additional information that any of you have, or any questions that you have about what I have presented, please do not hesitate to contact me. Again, I'm really sorry that I couldn't be